Good evening, ladies and gentlemen, and welcome to our physics lecture class. And in this lecture class, I'll just be explaining on circular motion. As you can see, there are two animations there. So both animations are just simply trying to explain what circular motion is. So please make sure that you follow up the class and make sure that you are able to understand. So at this point, I would love to confirm if you guys are able to get me or not. Can you get me? Can someone just confirm with me?
We're able to get you.
All right, thank you very much. So in this class, we'll look at angular motion, which is the same as circular motion. And this is just my part 1 lecture class and on this particular topic. So we can easily start and look at what rotational displacement is. So if you remember linear motion, we had things like displacement, we had things like distance, we had things like velocity. So these are the same things we'll be talking about even in circular motion, just that there is a little bit different. So when you talk of rotational displacement in linear motion, it's just called linear displacement, or in terms of something you can easily relate, we are simply talking about the distance. Okay, like just that the distance, it is a scalar quantity, whereas displacement, it is a vector quantity. So rotational displacement, which is represented by theta, rotational displacement is normally represented by theta. So we can consider a disk that rotates from point A to point B. So if you look at this disk, it has moved from point A to point what? To point B. And it is forming this angle, which we are calling the what? The rotational displacement. So the rotational displacement is just the distance which an object has covered from point A to point B. Then angular displacement, which is the same as rotational displacement, it is measured in revolution, degrees, or radians. So these are the three measurements which are normally used in angular motion, and these measurements are normally related to each other by following that equation. So 1 revolution is equal to 360 degrees. 1 revolution is equal to 360 degrees, which is equal to 2 pi rad. So this one here, 1 rev, it is talking about the revolution, which is the first concept. Then this 360 degrees is talking about the degree measure, and lastly 2 pi rad is talking about the what? The radian. So all these measurements, you need to make sure that you know them and the relationship between them. Okay, so with this in mind, you also need to understand that the best measure for rotation of rigid body is the radian. The best measure amongst the three, the best measure which you are supposed to use is the what? Is the radian. So most of the questions or most of your answers when you talk about the angular displacement, which is theta, your answer should be in what? In radian. We'll talk more about this. Let's quickly look at the definition of a radian. Let's see. So 1 radian is the angle, okay, subtended at the center of the circle by an arc length s, okay, an arc length s equal to the radius r of the circle. So the radian, 1 radian, okay, is just the angle. This is the center of this particular circle, isn't it? So this is the center. So it's just the angle which is made by an arc length. So the arc length, it is this S, which is the arc length. And this arc length is equal to the radius of the circle, which is simply equal to what? R. So from this definition, we can come up with the formula of finding the displacement or the angular displacement. So please take note of the formula. So angular displacement is simply equal to the arc length over what? Over r. The arc length over what? Over r. That is how you can find the angular displacement. Let's quickly look at an example. This is how examples are. Remember that this guy, remember that the arc length is normally in centimeters, the radian is in centimeters, the radius is in centimeters, but the theta is normally in terms of degrees. It can also be in radian. So let's quickly look at this example. A rope is wrapped many times around a drum of radius 50 centimeters. So this rope is wrapped many times around this car. Okay, how many revolutions of the drum are required to raise the bucket to a height of 20 meters? Now this becomes very interesting. Why has it become very interesting? Here, what we have been told is that the radius of this circle is simply what? Is simply r, and it is 50 centimeters. Then there is this rope which has been wrapped. So this rope which has been wrapped, it is pulling this bucket, and this bucket has been pulled by how many? 20 meters. Okay, so with this information, remember your unit should be in what? Should be in the SI unit. So what you're going to do, you're just simply going to use the formula. You're going to find the angular what? Angular displacement. Guys, let's go back. Let's go back and look at this. This is the angular displacement, the theta here, and we are looking for the revolution. But this same theta, this same angular displacement, which is theta, it is having this relationship. Now from this relationship, we are also having another relationship, which is this relationship. So theta is equal to arc length over what? Radius. So from this question, the first thing we are going to find is the theta, okay, the angular displacement, whereby we are going to treat this height as the arc length, since for this bucket to move from down there to 20 centimeters, meaning the rope which is forming the arc length has also moved 20 or 50 centimeters or 20 meters. So if the rope has moved 20 meters, then the arc length is also 20 meters. Even the height is 20 meters. Then the radius, it is something that won't change. It's still 50 centimeters. So the first thing we are going to find is the theta, the angular displacement. So in that case, we use the formula, which is pi or theta is equal to S over R, which is equal to 20 meters, which is the arc length, okay, because the pull of that rope, it is leading to the formation of the arc length in that particular rim, over 0.5. I've said these are the centimeters, so you need to change into the SI unit, which is 0.5. So if you say 20 divided by 0.5, it's equal to what? 40 rad. Some of you may cancel that meter and that meter, but when you cancel those meters, so long you are dealing with the arc length and the what arc length and the radius, then you are simply looking for theta. Now from this question, what we have been asked is to find the number of revolution. So when you use this formula, you need now to look for that relationship we had, which is 1 revolution is equal to 2 pi rad. 1 revolution is equal to 2 pi rad. We have the pi, which is 40 rad. So you are going to use that formula, and this is how you are going to derive at that particular point. So once you do that, your answer will simply be equal to 6.37 revolution. 6.37 revolution. This is your final answer. We have just used those two formulas. The second formula, we used it to find the pi. Then the first formula we talked about, it is a relationship, and it's the one which has given us what? Which has given us the number of revolution, because this can be said to be x, then you say is equal to what we have, which is 40 rad, okay, which is 40 rad, and then you just simply cross multiply, and this is what you are going to have. Simple and straightforward. Is there anyone with a question at this particular point before I move on? Any question? Timothy, do you have a question?
No, it's okay.
All right, okay, that's good. So let's move on and look at the second example. A bicycle tire. Yes, Florence, what's your question?
So I have a question here on the formula. Is it a must that 1 revolution is equals to
2 pi rad. Yes, Florence.
Yeah.
This is our formula.
It's a must.
Yes.
Alright.
A formula will always remain a formula. It will never change. Alright, let's move on.
Alright, thank you very much.
You're welcome. The second example is a bicycle tire has a radius of 25 centimeters. Remember, that is 25 centimeters. You need to change it to meters. If the wheel makes 400 revolutions, how far will the bike have traveled? If you understand this question, you're going to understand that they are looking for the arc length, isn't it? Which is the S. They are looking for the arc length, which is the length. So it's just playing around the formulas. So let's quickly go in details. So what you are going to understand is that theta is equal to 400 rev 2 pi rad. So here I'm changing the what? The revolution into the radian. I'm changing the revolution into the radian. From the formula there, which is 1 rev, which is 1 revolution is equal to what? 2 pi rad. 1 revolution is equal to 2 pi rad. So now I have 400 revolutions. I have 400 revolutions. So since I have 400 revolutions, I can easily make the what? The radian subject of the formula. I can make the radian subject of the formula. So if I make the radian subject of the formula, I'm going to simply have that particular guy. So from that, I'm going to have pi or theta is simply equal to 2513 rad. 2513 rad. Remember, this pi has also been multiplied, okay? That pi there has also been multiplied. So you say 400 times 2 pi. It's going to give you 2513 rad. So this is my radian measure. Now, after I have my radian measure, which is my angular displacement, I can easily look for the what? I can easily look for the arc length, which is S. So what I'm going to do is I'm going to say S is equal to theta r, angular length times radius. So from there, what I'm just going to have is that answer, which is the bicycle had to move 628 meters. So here I've just played with the what? With the formulas again. I've just played with the formulas once again. Okay. So with this in mind, I don't know if there are any questions. Catherine, do you have a question? Okay. All right. Let's move on.
No, I don't have a question.
All right, that's good. Okay, let's look at angular velocity, which is denoted by W. Guys, I've given you angular velocity, the angular displacement, isn't it? Now I'm talking about angular velocity, which is the same as linear velocity. The same velocity we are talking about when we are talking about motion in one direction or linear motion. When we were talking about that, we are now talking about angular motion. So this is now angular velocity, which is denoted by a W like that. So after that, we need to understand that angular velocity is the rate of change in angular displacement. That angular displacement we are solving now, it has to be related with the angular velocity. So it is radian per what? Per second. Radian per second. Now, this gives us that formula. So angular velocity is equal to change in angular displacement over change in time. Just the way we say change in displacement over change in time. That part which we were learning on linear motion, it's the same thing that you also talk about angular velocity. So angular velocity can also be given as the frequency of revolution. Remember that radian is related to what? Radian is related to displacement. A radian is related to revolution. So since radian is related to revolution, even angular velocity is also related to what? Frequency, because frequency is as a result of what? Revolutions. So angular velocity can also be given as the frequency of revolution, which is just the revolution per second, and that is the formula. Guys, angular displacement is equal to 2 pi frequency. That is the formula. So if you have the angular velocity, they ask you to find the angular frequency, then you are going to divide that angular velocity by 2 pi. That's 2 pi we had from the revolution. It is the same 2 pi which has come. So this is the relationship between angular velocity and the frequency. This is the relationship. This is how to find the angular velocity. This is how you can find angular velocity is equal to change in displacement over change in time. And you know that change in displacement is equal to arc length AC over the radius. So it's something that is now building up slowly until it shall become one. Until in the next topic we'll talk about angular momentum, angular work, energy and power. Then we are done with the topic. But everything everything is hiding here. This is where the basic is. Okay? The same way the basic was for vectors. Vectors formed the basic of everything we have been doing up to momentum. Now, this information is forming the basic, and we are going to be borrowing some knowledge from vectors. So if you miss this, then you won't be able to know angular momentum, angular work energy, and power. You won't be able to know those three. So let's move on. This is the relationship between angular velocity and the frequency. So we can easily move. Let's look at an example there. A rope is wrapped many times around a drum of radius 20 centimeters. What is the angular velocity of the drum if it lifts the bucket to 10 meters in 5 seconds? Someone who was following can see and understand that from this question and the previous question, the only thing that I've added is what? Time. The only thing that I've added, it is time. But everything is what? Is the same. So I do wonder why people fail physics. The reason they fail physics is you don't understand the basics. So here I've given you the basics of angular displacement. I've given you the relationship with revolution. Then I give you angular velocity. From there, I give you its relationship with frequency. And now I'm giving you an example. So how can we go there? This question. The first thing, look for the what? Angular displacement. Using the formula, angular displacement is equal to arc length over radius. So the arc length, it is the same height which has been utilized, which is 10 meters. The radius is 20 centimeters. When you work out that, it's surely going to give you what? 50 rad. Once you are done with 50 rad, you find the angular displacement. You go back and utilize what? That formula. Change in angular displacement over change in time. So go there and use that formula. W, angular velocity, is equal to change in displacement over what? Time. So 50 divided by 5, the answer is simply 10 rad per second. If it was linear motion, this would have been what? 10 meters per second. But now we are not going to use 10 meters per second because this is what? This is angular velocity. So we are going to say 10 rad per second. Easy. You are done. It is from this. Okay, that's why I'm telling you. This is the basic. If you look at angular velocity, it's going to give you the angular kinetic energy. Right? Because where there is V in kinetic energy, you'll be putting W. So that's how easily you can solve that. Do we have any questions, ladies and gentlemen? Any question? Ruth, do you have a question?
No, I don't have any question.
Okay, that's good. Let's move on to example 2. Example 4. In the previous example, what is the frequency of revolution for the drum? What is the frequency for the drum? So now here, this question, it is a building up of that question. So here you are going to use that relationship we had, which is the angular displacement is equal to 2 pi frequency. What does that mean? We can now easily work out our question, and that is you're going to say W is equal to 2 pi f, where W is the angular velocity, F is frequency. When you divide throughout by 2 pi over 2 pi, it's going to give you that. When you plug in the values, 10.0 rad per second over 2 pi rad per second, your answer will simply be what? 1.59 revolution per second. That's all. Or you can use that particular formula in case you want to put it in minutes, but I'll prefer you to leave your answer in 1.59 revolution per second, because the second is the SI unit. But in minutes, you're just going to multiply it by 60 seconds, and this is what you are going to have. Done. Chishimba, do you have a question? Is it clear?
It's clear, sir.
Okay, that's good. Okay. Now, look guys, what did we start with? Angular displacement. Next, angular velocity. Now we are where? Angular acceleration. The same way we have linear displacement, linear velocity, linear acceleration. Now we are on angular acceleration. Okay, so angular acceleration, this is the rate of change in angular velocity, which is radian per second per second. So this is how you represent angular acceleration, which is alpha. Alpha is equal to change in angular velocity over change in time, and the SI units are rad per second squared. The angular acceleration can also be found from the change in frequency as follows. So this is another formula which you are supposed to know. Angular acceleration is equal to 2 pi change in frequency over time. 2 pi change in frequency over time. This formula and that formula are related. There are some questions where you need both of them. There are some questions where you are going to need the frequency. There are some questions where you're going to need the angular velocity. So with that in mind, we can easily look at the example. The block is lifted from the rest until the angular velocity of the drum is 16 rad per second after a time of 4 seconds. What is the angular acceleration? So here I think I've explained this. You're just going to say angular acceleration, which is alpha, is equal to angular velocity minus angular velocity final minus angular velocity initial. Since it's starting from rest, that means that this angular initial angular velocity is what? Is 0. So this will be equal to that. Then when you plug in, your answer will simply be that value, which is alpha angular velocity is equal to 4 rad per second squared. 4 rad per second squared. Okay, so with this information, we can look at the relationship between angular and the linear speed. So from the definition of angular displacement, you have to understand that S is equal to theta r, which is linear versus the angular displacement, where this S is talking about linear and that is like that. So from here, you have to understand that velocity is equal to change in distance over time, which is equal to this change in S, which is that S is equal to change in displacement times radius over change in time. So this is simply equal to change in what? Change in displacement over change in time. And this change in displacement over change in time is the same as the angular velocity, and the r is just the radius. So this formula is the formula which relates the velocity and the angular velocity. The velocity we were learning when we are talking about linear motion, it is related to the angular velocity through that particular formula. So you have to know that relationship. So v is for linear speed, angular speed is w, and the radius. So linear speed is equal to angular speed times the angular speed times the radius. Please take note of this formula. Okay, angular acceleration and linear acceleration, the relationship can also be established. So from the velocity relationship, we have v is equal to wr, linear versus angular velocity, which I've already explained. So from here you can say velocity is equal to change in velocity over time, which is acceleration. This has to be angular acceleration there. Angular acceleration is equal to change in velocity over change in time, which is equal to change in velocity dot r over change in time, and that particular part is simply equal to angular velocity, angular acceleration. This guy is the same as the angular acceleration. So this is the relationship. Acceleration, the normal acceleration, you know, is equal to the angular acceleration times the radius. Same thing as that, just that where there is linear velocity we are putting acceleration, where there is angular velocity we are putting angular velocity. So this is the relationship. Linear acceleration is equal to angular acceleration times the radius. So that's the formula. Let's look at the examples. So consider flat disks. So you have the flat disk. There is the first radius, which is from here to there. Then there is another radius which is from there to there. These concepts we are going to utilize them later on. So W1 is equal to 0, which is the initial angular velocity is equal to 0, and then let's say final angular velocity is equal to 20 rad, and the time is 4 seconds. What is the final linear speed at point A and the point B? So you're having two radiuses. There is the radius which is 20 centimeters, which is from here to there. You're having also the radius which is from there to there, which is 40 centimeters. Then they're asking you what is the final linear speed at point A and at point B. Remember, you have been given that as your information. So at point A, you're just going to say 20 rad times 0.2 meters. 0.2 meters because R1 is what is 20 centimeter, which is 0.2. So I'm just going to multiply 20 times what? 20 times 0.2, which is that. Then there at point B, you can just simply say 20 times 0.4, which is going to give you that. So these are the linear value, the linear acceleration. I think I'll go much in details in my next classes, where I'll be solving some exam questions. For linear acceleration, consider the flat disk, that. So for that, you're just going to find the angular acceleration, whereby you say 20 rad over 4, and that will give you the angular acceleration to be equal to 5 rad per second squared. To find remember we need the angular acceleration. So this is the angular acceleration. You just say 20 rad over 4 second, just from that formula. Then the linear acceleration, you're going to multiply this by 0.2, again this by 0.4, and that's what you are going to have. So at point B, since we want point B, you're just going to say 5 times 0.4, and it's going to give you what? 2. Okay, so you need to, I think I don't really have to go that far. I have to go with comparison between linear motion and the angular motion. So from here, this is just helping you to remember, in case you are able to remember linear motion but you forget angular motion. So these are the formula. S as your distance is equal to change in velocity times time, which is equal to V initial plus V final over 2 times time. So the same formula, where there is V0, you're going to be putting W0. VF, you're going to be putting WF. W0 is simply talking about the angular velocity, the initial angular velocity. Then this V0, the one you know and familiar with, it is talking about the linear velocity. The other formula we know on linear velocity is VF is equal to V0 plus AT. So this is the formula most of the time we know. We all know this formula, the first equation. So WF is equal to W0 plus angular acceleration times time. So same things. Where there is acceleration, you are putting angular acceleration. Where there is V0, you are putting angular velocity. Same applies with this other equation, where we say S, which is distance, is equal to V0t plus half AT squared. So where there is S, it is theta, and W0, it is angular velocity initial, and where there is acceleration, you're putting alpha. Same applies with that one, same thing, same explanation, and the last one is still the same. So these are the 5 equations in linear motion which you know, which I taught on linear motion, and these are the comparisons, how they are related, like they just exist as the same things. Like you look at the linear motion, a car traveling initially at 20 meters per second come to a stop in a distance of 10 meters. What was the acceleration? So if this is a question from linear motion which we did, so you're going to use the equation, this equation 2as is equal to v squared minus v initial squared. So when you work out that, you're going to find that acceleration is negative 2.0 meter per second squared. So this is what I taught on linear motion. This is what I taught. But if you look at this question is from linear motion, isn't it? But we can have a question of this same type in angular motion, you see? So a disk 50 centimeters rotates at 600 rev per minute, comes to a stop after making 50 revs. What is the acceleration? So here you just say the equation 2 alpha theta is equal to w squared minus w squared. So this is the same equation we used here. This equation, it's the same equation we have now used there. Okay, so this will be our revolution. Then there we have the initial. Okay, then there we have the s, which is the distance. So you're just going to replace you're going to find the rad. You change this revolution, 600 revolution per minute, you're going to change it to rad. So when you change it to rad using the formulas I gave you, you are going to find that the velocity will be 62.80 rad per second. This is the initial. Comes to a stop after making. So this comes to a stop. It means that's the final, which is 0. So 50 revolutions is equal to 314 rad. This one we are borrowing the knowledge from the first formula we were doing. So 314 rad simply means that we have theta, which is 314 rad from the knowledge from the first equation I gave. Then you can use the formula, and that's how you're going to have 0 minus w squared over 2 theta. We just make theta subject to the formula. So when you plug in those values, it's going to give you something like this. So this is just an explanation, a brief explanation about rotational motion and what you need to know. But more revisions, I'm going to give more revisions in the coming classes where I will explain more. I think, ladies and gentlemen, this marks the end of our today's class. So if you have a question, you can ask right now, and in case you're going to have a question afterwards, you are also free to WhatsApp me. I'll send the notes.